students will submit their attempt sheets to me for the questions attempted, for the questions they attempted. When I say attempt sheets, I mean, you'll be solving them somewhere. So I would want you to solve them properly, and you can, submit it to me by an email. So submission on properly solved questions on A4. Now, if a student is getting, see, because it would be just like checking copies of people as if the paper was a subjective paper, because what I want to do is that even though the examiner is going to give you some marks, but I would not be able to see what procedure you've applied. So if you've done the question right to some extent, I will give you some marks, and that some marks is not going to be up for scrutiny, because uh, the test is actually an MCQ, but this is something that I'm doing just so that the students don't feel disadvantaged, that they probably did some steps correct and they got the answer wrong ultimately, and they've not been given any step marking. So I'm going to do that, but the condition is that you have to properly solve them at the time you're giving the exam. And the exam, what is the date for the exam? Can anybody tell me what is the date?
Sir, 24th.
Yeah, 24th. What is the time? What is the time for the control system? I think it's in the evening, is it?
Sir, yes, sir, 4 to 5, I guess.
I think it is from 4:30 to 5:30 then.
Yes, sir, 4:30 to 5:30.
Yeah, so if it is from 4:30 to 5:30, once you submit your this thing, you submit your examine. I'm going to take the paper on examine, and just to ensure that you people don't feel that there's randomization and everything. I mean, there isn't any randomization this time. It's just that it's basically a platform to be able to take subjective exams. I don't trust Google Forms because uploading files can be tricky there. So we have an exam from 4:30 to 5:30 p.m. and I would want the submissions on properly drafted solutions on A4 by 5:45 on my mail. If anyone submits after 5:45, I am not going to consider it. No matter what, even if that person is failing, I'm not going to consider it. There is some level of strictness we have to show for submission. Email, anybody can send an email. An email does not take time. Even if you have very low speed, the email will go. So there should not be any excuse. What you do is that once you've submitted it, you make a PDF, and please send me a PDF. Download some cam scanner or clear scanner or something. I want you to take pictures of whatever you've done and you send it to me. And I would be particularly interested in your solutions if you have scored less than 25. If you've scored greater than 25, then your paper I will see, but I'm going to see them the last. So I'll be more interested to look at how the people who are scoring less than 25 have, tried to solve the questions. So though everyone's paper is going to be checked, but my focus will be to, ensure that I could, do some justice to the steps that you have done in the paper, or while trying to come to an answer and then answering it in the exam. So that is what it is. So there are a couple of things which I'm trying to do a little differently. I do not know how much successful I will be in it, but this is something that I have thought. Trying to make the paper as close to as it would have been had you been giving an offline subjective paper. Now, examiner also has an option of subjective questions now, but they take LaTeX as the input, and writing LaTeX and understanding LaTeX is kind of slightly difficult right now, considering that we have very little time for the papers. They're starting from 19th and today's 14th. So I think probably what we'll do is that I will put up some videos and I will give some instructions on how to actually write LaTeX documents. It was to be a part of your technical writing sessions, but I think probably that lesson that I will give in the technical writing component has not come yet. But I want you people to know how to do it, because the second midterm, which happens on between 17th to 19th November, that is what the dates we have decided. It's not going to be an exam, it will be a continuous evaluation. So you will be given a small project and you'll be working in groups. So there, whatever document you will submit, that has to be written properly using LaTeX, and it should not be just a shabby written document. So there I would, so for that I think we still have a lot of time, and it's a very simple thing if you have maybe 10-15 days to learn it. So that I'm going to do, but I hope that this pattern is clear. So the idea is that you will have a test from 4:30 to 5:30 p.m. and you will get marks using your MCQs, whatever you answer. But the questions are subjective type. The questions are subjective type, and so what I can do is that I can upload. Okay, so what I'll do is that once the test starts at 4:30, I'm going to okay, I'll come to that later. Questions are subjective type, so you'll have to solve them. And you'll select the answer. If the answer is correct, well, great. If the answer is wrong, then there is a problem, because you would say that sir, I've done so many steps and I have not been given marks for my steps. So for that you will submit A4 on A4 paper, properly written solutions, and I would want PDFs only. I don't want images with your cameras, which I cannot read, because then I would just probably not see it. So download something like this, I'll tell you what you download for that. You download something called as Clear Scanner. And you click an image and convert it into PDF, and then you use it wherever. So then what I'll do is So once the paper starts at 5:30 p.m., I'm going to upload that paper on Classroom as assignment. And I would set the time of submission for this assignment that day only, and it will be due on 24th 5:45 p.m. So once you submit it and if it's late, then I will not consider it. 15 minutes is a lot of time for you to create a document and send it. So I want to also discourage cheating in this period of 15 minutes where people just keep sending each other their solutions. And if I find two solutions almost similar, even if it is word to word, because generally if you have correct solutions, they are similar, I don't have a problem. But if I see that there is a solution which is incorrect but it is same, then those two students will have a problem, and I'm not going to check their papers. Whatever their marks are there in Examiner, they are there in the Examiner, and I'm not going to do anything. So I'm doing this to give you consideration based on the fact that the questions you'll have to solve. But if I see that there has been a use of unfair means, I'm not going to check it. And the marks that you obtain from Examiner is going to be the final marks that you will obtain. Then I'll be particularly interested in those students who scored less than 25. So I will definitely give due consideration to them. But if anybody is scoring 40, 45, well, their papers will definitely be checked, and if I can increase their marks slightly, I will. But my focus over here is primarily on students who will be scoring low. So that is what it is. And if there is any suggestion that you want to give, then you can give, and then probably we'll go discussing a couple of questions. So is this okay? The strategy that I'm adopting. If you have feedback on this, हाँ या ना तो बोलना होता है, साइलेंस नहीं रखना होता.
Sir, it's good.
So lastly,
हाँ.
we
Yeah.
have to submit that PDF in Classroom only, Google Classroom.
Yeah. So basically, what I'll do is that okay. So what I'll do is this. I will set the Examiner in such a way that you're going to get your scores also. So I think the scores will come right at the time when the paper ends at 5:30. So I think they'll be just maybe, or what we can do is that, okay, so maybe not 4:45 or not 5:45. What we'll do is I'll test it how soon you get the score. So I'll do it myself. So let's give you slightly more time. Let's make it 5:55, because I'm going to be anyways checking for any unfair means. So by 5:55, or what? 5:55 doesn't make any sense. 6. So by 6 p.m. I would want you people to submit it. Anything which comes after 6 p.m. will not be considered. Number one. Number two is once you get your score, let's say that you're getting 45 or maybe 40, because every question is for 5 marks. So if you're getting 45 or 40 and you don't want to submit, then you just write a note in your submission that I don't want the paper to be seen. Or what you can do is that you would also come to know which questions you've done wrong. So you can just submit those questions, and then maybe I'll have a look at it, and then probably I'll increase your marks based on that. So I mean, what would be a good idea is that for people who are scoring more than 25, if your marks are more than 25, then maybe in another 5 minutes you'll get a mail where you'll have a detailed analysis of your scores and review. And once you get that review, the questions you want that I should look into, you just send that. But I would want to see the entire solution of people who are scoring less than 25. I would want to see the entire solution. So that is what it is. हाँ, आप बोलो क्या बोल रहे थे एक बार कशिश?
पूछ रही थी सर वो पीडीएफ क्लासरूम में अपलोड करना होगा ना लास्टली जो आप क्रिएट करेंगे मतलब
हाँ सो मैं ना जैसे ही पेपर स्टार्ट होगा, as it is you'll get all the questions when the paper starts, because you can just click in it and you can see. So what I'll do is that I will maybe at 4:40 4:45 I'll upload an assignment of the Google Classroom, which will be just the question paper, and for that assignment the due date is going to be 24th only, and the time is going to be 6 p.m. By that time you will have to submit the solutions. If you have less than 25, I would like to see every solution of yours, all the 10 questions. If you are scoring more than 25, then once you get the score, you'll know which question has gone wrong, and if you want to show me what you've done so that maybe I can give you some marks on step marking, then you send me that those questions only you send me, and you just write a small note maybe at the top that I'm only sending those questions that I want you to look into. But I repeat again, for people scoring less than 25 in their examiner exam, I would want them to send the entire set of that. And if it is legible only, then I'll be able to check. If you scribble around here there, then I'll not be able to check, and I will just simply turn it back saying that I cannot check it. So please do the paper as seriously as it is being done if you're sitting in a class and doing a paper. Okay, so get some A4 sheets, and it is always good to do it on A4 sheets, because sometimes the quality of the ruled paper is really bad, and some of the assignments that I've seen, they've been done on a a really poor grade of paper. Try to get A4 sheets and solve questions on that. So I hope I have answered your question.
यस सर.
हाँ, और बोलो अगर किसी को कोई और भी कुछ पूछ रहा था. If there is anything else that you'd like to discuss on this pattern, I hope you're okay with this pattern, right?
Yes, sir.
Because
Yes sir.
yeah, because I want to give you step marking, like last time when we were doing numerical methods, you were solving a paper and I had a paper in my hand and I gave you marks. With MCQs, it's like either I give very stupid questions that everybody can solve maybe in 1 second or maybe 5 seconds, but that doesn't really work. So I want to give you a paper just so you feel that you would have given that paper in the offline. So this is the strategy that I've come up with. The similar strategy I will adopt in DSP also. So probably I'll have a short discussion with DSP. Most of the students in DSP are you guys only, so we know. So I think if this is clear, then maybe we can discuss a couple of types of questions that maybe you should look into and focus your attention to. Can we move to that, or if there is anything else that you want to talk about here? Okay, so I think let's just move to some discussion on the types of questions. Okay, so the broad category of questions are going to involve concepts of block diagrams. You will have questions on signal flow graph. And you will have questions on state space approach. This actually constitutes about 1.5 units of your syllabus. These are the main topics. Okay. In state space model, if let's go. So let's go one by one. So if you have block diagrams, then all these three things are interrelated. You can have a state space model, and you can create a signal flow graph, and you can create block diagrams. So there could be a question in which there are two or more concepts involved. So those kind of things are going to be there. So block diagrams, you can have block diagram reduction. So you just remember a little bit of that concepts that we had done. We had done some manipulations and we had done some reductions. So you should know those things. So that is one thing that you people should know. Then in signal flow graphs, you must know the properties, or let's say the rules on the basis of which the signal flow graphs are created. You should be able to find the transfer function, which is basically the Mason's gain formula. So you must know the Mason's gain formula. If you remember, it was summation mk delta k over delta. So you have to know this. Then a block diagram will give you a signal flow graph, or a signal flow graph will be there, and maybe you'll have to create a block diagram. So those kind of things are some things that can happen. And there is an option in Examiner in which I can put up pictures also as answers. So don't think that because these are diagrams they cannot be asked in the paper. I can upload a figure, I can upload figure in a question, I can upload figure in answers. So you can get questions on block diagram reductions, and you can get questions on this is a signal flow graph, what will be the block diagram. So those kind of things can be asked. So do prepare them, because I want to make this paper as close to as you giving an offline paper. So such things can be asked. Okay, so this is basically block diagram. Yeah. Okay, so then when we come to state space model, the first thing is that, of course, you must understand this formulation, and you had y is equal to cx plus mu. Of course, there is a disturbance also, but I'm not writing it here. So you must realize that everything has to be brought into this, and you should know how to choose state variables, as we had discussed. So this is only electrical circuits, state space models of electrical circuits. So what you can get is that you'll probably, in some questions, you get a diagram, and you have to create the state space model. That is probably the simplest and the straightforward question that you can get. You can get an ordinary differential equation, and you could be asked to create a state space model. You could be given a state space model, and you could be asked to create the ordinary differential equation for it. So you have to go reverse also. Or you could be asked to create a signal flow graph. So basically the diagram, what I mean, not diagram, you could be asked to create a signal flow graph. So a state space model will be given. You will be asked to either create a block diagram or a state signal flow graph. So those kind of questions. Sorry. And so there is another thing that could be asked, is that you could be given a transfer function, and you could be asked to create a state space model. So all those kind of things, all these things are interrelated, and so those kind of questions could also be asked. So these are basically the kind of questions you need to prepare. I will also put up some questions as practice problems, and then you can look into it. But I don't have that much time that I'll be able to put up solutions. If I get time, I'll definitely put them up, because the coming few days we are going to be really very busy with JOSA counseling and some purchases that we are doing for the school. So I will definitely get time to take the classes. I'll find time for that, but I can give you some practice questions and solutions. I'm not very sure whether I'll be able to put it, because I'll give you some 10-20 problems and there'll be subjective problems from 2 only, and so just so that you get a feel of what kind of questions can come, so you can just look at them and try to solve them among yourselves. That will be a good thing. So these are the kind of questions that I'll be asked, and the questions are pretty straightforward, in the sense that if you know the concepts and the interlinkages, you will be able to solve them. There are a couple of questions also in the paper that are very straightforward, in the sense that anybody who has attended the classes regularly and with a little bit of seriousness, they will be able to do. So passing the paper is not going to be a problem, and I don't want to create a circumstance where you cannot pass a paper, whether we are online or offline. But I would want you people to apply the concepts and apply your minds when 2 or more number of things are being interlinked. So those kind of things should happen. And I think that I'm not going to. Do you want to solve some problems as practice problems right now, or that's it? Because I just wanted to explain the format of the paper as such. But if you want to solve some problems, then we can solve some problems. Otherwise, we can just leave. So what is the suggestion? Is the class coordinator here? Anmol is here? Anmol is not here? Okay. So the silence tells me that you want to leave. That's okay. As it is there.
Sir, we can solve some.
Oh, we can solve some. Okay.
Yes, sir.
I hope that's the. We'll solve some questions. Okay. So let me just let me do a couple of things. Just a second. Yeah. Okay. Then we'll solve a couple of problems, just for some clarity on intending things. So I think if a differential equation is given to you, you can create a state space model. Yes or no? So just quickly try to do this problem. If I say,
Yes, sir.
if I say d2y by dt square plus 2 dy by dt plus y is equal to ut. Can you create a state space model for this?
Yes, sir.
It's very simple. You will just take y as x1. You will take dy by dt, which is x1 dash, as some variable x2. And because the order of the differential equation is 2, the number of state variables that you will require is 2. So you have already got them. One is x1 and the other is x2. And d2y by dt square becomes x2 dash. So one equation is here and second equation is x2 dash plus 2x2 plus x1 is u. So x2 dash is x1 is 2x2 plus u, and x1 dash you are evaluated as x2. So here is your state space model. So if you know it, it will not take you more than 5 steps to get the answer. So that's number one. So I think this is clear. So I think no matter what differential equation it is, no matter what degree it is, I'm sure that you will be able to create a state space model. So that's probably one of the things. Then let's look at this thing from another perspective. Suppose suppose I say that you have a transfer function given to you. Suppose I say that it is b naught over say s square plus a1 s square a2 s plus a3. If I give you something like this and I ask you that the output is y and the input is x, and then create a state space model. So how do you go about such problems? I mean, it's very simple. It's just that you will write something like y upon x is equal to b0 a1 square plus a2s plus a3, and you take it on this side, so this becomes a1s square y plus a2sy plus a3y is equal to b naught x, right? So now, because it's transfer functions, we assume that the initial conditions are zero, so they'll be zero no matter how you solve and when you solve the problem. So now, if you look at it, what we can do is that if I take the inverse Laplace, so I get a1 d2y by dt square, because that is s square ys, plus a2 dy by dt plus a3y is equal to b naught x. Now you get a differential equation from this transfer function by taking the inverse Laplace, and then you follow the same principle here and you will get an answer. So this is basically that you've given a transfer function and you have to formulate a state space model. Now, if suppose I say so, if I give you a differential equation, then can you formulate a signal flow graph? Yes or no?
Yes, sir.
That is simple, right? You just try to write it in. You just take the Laplace transform. So if you're given a differential equation and you have to create a signal flow graph, what do you do? So this is another type of question that is possible. So you're given a ODE. So suppose you're given something like d2x by dt square plus x equal to, actually this will not really work. Suppose if this is given to you, and then you'll get x everywhere. So I don't think this could be. Let me just try to find a question for this. Just a second. Let me just think about it. In the meantime, we can solve some other problems. If suppose I give you a signal flow, okay, this is an important concept. So we'll come to this. Let me just think of some problem. But let's come to this. So suppose in a block diagram, I say that there is an integrator between these 2 points, then in a signal flow graph, what would this integrator be replaced by? Integrators are replaced by 1 upon s, because if you remember, if you have a function x tau d tau, then when you take a Laplace transform, then it becomes 1 upon s. So integrators are replaced by 1 upon s. So you should remember this. Differentiators, if they are, well, I mean, they'll be replaced by s. So this is an important thing. So this is going to be useful if suppose I give you a block diagram in which there are integrators or differentiators and you have to convert it into something. So, if I give you a block diagram and you have to convert it into a signal flow graph. So let me just think of a problem of this type. So let's just first look at the opposite problem. Suppose you have a signal flow graph and you need to find an ODE. So how would you go? So the first thing that you are going to do here is that you are going to find a transfer function. So this is something that you will evaluate. Okay, so once you evaluate this from here, so you get a form which is HS, which is YS over say US, and once you get to this form, then you're going to you're going to do basically your YS is equal to HS US, and then HS is going to be of the form PS over RS US. Then you're going to write it as YS into RS is equal to PS into US. Then you're going to take an inverse Laplace, and once you take an inverse Laplace, you're going to come to an ODE. So basically this is the way that you will come from a signal flow graph to ODE, and then if you trace your steps back, you will move from an ODE to a signal flow graph. That means you have an ODE, you take a Laplace transform and you come to HS, and once you have HS, then you write it in such a way that you are able to get a signal flow graph. If you remember, we did some problems based on that classes back, in which you had S square I, and on the other side also you had I, and then we were like kind of taking the S square of the other side and trying to write something. So those kind of things perhaps we can look into. What else can be asked? I can't really think of anything else. I've not made the paper yet.
Sir,
So yeah.
so in differential equation, like we have given a differential equation, then we will
Yeah.
take the Laplace first. So,
Yeah.
sir, if it is not given that initial condition is 0.
So if I give you that the initial condition, so if you have a signal flow graph and you are calculating a transfer function, then in this approach you would assume that the initial conditions are 0. And if you have a ODE from where you are going to signal flow graph, then yes, you may have some initial conditions there. Like for example, okay, so I think let's look at this. So suppose I say that you have d2x by dt square plus dx by dt plus x is equal to ut, something like this. So basically what would be the inverse Laplace transform of d2x by dt square? Can you guys tell me? If the initial conditions
S
are taken into consideration,
S
कौन बोले?
square
हाँ,
xs minus
minus s
small x s
So,
क्या होगा बोलो?
सर x z 0.
एस एक्स एक्स
नहीं सोचो क्या होगा, पता करो.
सर एक्सेस ही आएगा वहाँ पे, फिर माइनस एक्स ऑफ 0 प्लस मतलब x 0.
Yes, sir.
सोचो, थोड़ा सा लॉजिक लगाओ, क्या होना चाहिए? बताओ, मैं इंतजार कर रहा हूँ. If it's a double, if it's a second derivative, how many initial conditions you'll require to solve the differential equation?
2.
2. कौन सी होती हैं वो? अगर d2x by dt square वाली differential equation है, you would require a initial condition on x. You will require an initial condition on x dash, right? So it'll be x0 minus x dash 0. If you look at dx by dt, it will be xs minus x0. So if it was d cube x by dt square, dt cube, then if you take the Laplace transform, it will be x cube xs minus s square x0 minus s x dash 0 minus x double dash 0. Because to solve a third order differential equation, you will require 3 conditions. So one has to be x0, the other would be on single derivative of x, and then the other would be on double derivative of x. So this is how it goes, and then you can generalize it. So that's basically what I want to So I hope this is clear. So let's just come to the problem again. So if suppose you were to express this, what was it? Dx by dt plus x is equal to u. Okay, so what does this become? This becomes x square x minus s x0 minus x dash 0. This is what we get. Okay, then plus sx minus x0 plus x is equal to ut. Okay, so let's do one thing. Let me just just write x square x here, and then take everything else on the other side. So I get sx0 plus x dash 0 plus sx plus x0 minus x plus ut. Okay, so now if you look at it, and then maybe then I can write x as 1 upon s square. Then let me collect the x terms. So you have s minus 1x plus s plus 1 x0.
सर ये यूटी यूएस हो जाएगा ना?
I'm sorry? Yeah, so okay. UT will not be there. It will be basically 1 upon s. So actually sorry. So it will not be even 1 upon s because ut is just some input. So let me just call it not ut, but let me call it us. If it was a step, then it would be 1 upon s. So I just probably got a little confused with that. But let me just write it like us. So then I think I've taken into consideration all the terms like this. Okay. Let me just. So if you look at this, then there is some sort of a feedback which is happening along with addition of some inputs to get s back. So let me just add one more page and let me see how I can write this. Just a second. So I'll just say that f is 1 upon s square us plus s minus 1x plus plus 1 x0 plus x dash 0. Okay, so now on one side you have us. So this us goes, and let's say that on this side you have x here, 1, and then you have x here. So what is happening is that you have one branch going like this, which is basically s minus 1, and then let's say that you have an input x0 here, and then there is a branch coming like this, which is s plus 1, and then you have you can show it here only, or you can just come up here and you can show that there is this branch here which is x dash 0, and then once you add all the things, because here node means that things are getting added once we put the arrows, and if there was a negative sign, then I would have put a negative sign here, and then you just have this thing which is one of this. So this is basically how, using a differential equation and initial conditions, you can create a signal flow graph. And if I say that the initial conditions are 0, then this term goes away, this term goes away, then this goes away, this goes away, and then you just have a straight line with an inverse one loop. You just have 1 upon s square and you have this loop, and that's basically it. So you can get a question like this also, in which you'll have to create something like this. But if you have so coming to the question that was asked by, I think it was Sanya, I don't know, maybe.
Yes, sir.
Yeah. So basically the question is that in this kind of a problem, because there is a signal flow graph and you're applying Mason gain formula to evaluate a transfer function, then from the very basic definition of transfer function, we all know that can only be evaluated when the initial conditions are 0. In the signal flow graph also, presumably we will assume that they are 0. Because if you remember in one of the earlier classes, when I had given you a signal flow graph and I said evaluate the transfer function, then if some of the students who are here today and were present then would remember that I had deleted the initial conditions from those signal flow graph, and we were just given a signal flow graph and we would evaluate. So please remember that. So these are like, everything is interrelated. There is nothing new as a concept, but you should know how to interrelate one to another. That is basically the essence of things. And later on, once we go to higher units, or so then there you'll see that what we have learned so far in state space model, that we just create a state space model. Then what do we do with it? Of course, we need a solution. How do we find a solution? Then we check for whether that solution is stable or not. What kind of a transfer function can be obtained? Can that system be represented using a block diagram? So everything is interconnected, but we are definitely going to look at it systematically. So I don't want to develop any topic of control systems in isolation, because ultimately the idea is that these concepts help you to build a system. These concepts help you to analyze a system from the point of view of stability or controllability and other concepts of control systems that you study later. So I think we should just probably end the class now, because I don't have anything else to tell you. Pretty much every kind of a problem is covered, and towards maybe by evening 5:30 I'll put up some questions on the Google Classroom, and students are telling me that the videos are not accessible. and access is being denied to the previous class videos, what I'll do is that I don't know what is going wrong, but the safest thing is that I'll take those links and I will send them to you on your mail IDs. The registered mail IDs that I've obtained this time, most of them are GNU mail IDs. So just go through those lectures from your mail IDs. Okay, so just do that. If there is no question, then I think we'll just end the class.
Sir,
Yeah.
so you have mentioned about matrix manipulation last time. So what kind of questions can be asked from there?
Yeah, so matrix manipulation could be that I give you a state space model, so something like this. Just just a second. So yeah, so suppose I have a system like this, okay, and I say that. So the state variables are defined by this. Suppose I say that there is a new state variable y, which is some transformation of x. Then this transformation is a matrix in itself. Then if I ask you, what would be maybe the new state space variable equation, then what will that be? So that is basically what it is. So these kind of things come into picture. Let's say that you're trying to devise a control system that is probably rotating at some angle, or you want to rotate it. Then you want to see whether after that rotation, what would be the scenario in which the state variable will be. It's like a satellite is there, but you want to change it to a certain degree, and then you wonder whether if you rotate it by a certain degree, whether it will still be stable in its orbit or not. So for that you need to have a transformation matrix for that rotation, and then you apply it, and then you get some new state variables, and then you analyze the system on the basis of those state variables, whether the system is going to be controlled or not. So such kind of transformations. So then you'll have to do some matrix manipulations, because A is also a matrix, B is also a matrix, T is also a matrix, and you're converting things. So then you'll have those matrix manipulations, something like that. Okay, so I'm going to put up these notes on the classroom. I had a discussion in the earlier section of the class. I saw that there were not so many people there, and some of them have already left. But just go through the PDFs and maybe the video of this lecture. You'll come to know how I'm going to take the exam. And I'll see you now in the DSP class, which is tomorrow. All right. Take care. Have a nice day. Bye.
Okay, sir.
Okay. Bye.